Okay, so let's consider the series here as k goes from 1 to infinity of 1 over k factorial. Okay. Turns out the ratio test is really good for working with expressions where you're dealing with a factorial. Turns out it's really, really good for working with factorials because of some of the factorial arithmetic. So again, this is positive, so I won't deal with the absolute value here. So once again, I first want to convert or compute my ratio. AK plus 1 over AK. Right? That would be 1 over k plus 1 factorial over 1 over k factorial. That would simplify to be k factorial on the top over k plus 1 factorial on the bottom. K plus 1 factorial on the bottom. What can I say about this? How in the world do I simplify k factorial over k plus 1 factorial? Well, we talked about this a little bit, but it's worth revisiting here. K plus 1 factorial, remember, the definition of the factorial means take that thing times the next term times the term after that, right? And continue that pattern all the way down to 1. But what we can do is realize that we could write this as k plus 1, and then this is just k all the way down times k factorial. Okay, so this is a kind of a common thing with factorial arithmetic that we can strip off a piece, and that's advantageous here because the top is k factorial, the bottom is going to be k plus 1 times k factorial. And so what we're able to do is cancel out those k factorials. And we're left with just 1 over k plus 1. 1 over k plus 1. And so now we're ready to talk about the convergence, because now we have our expression ak plus 1 over ak. So now we're ready to take the limit of that thing as k goes to infinity. Limit as k goes to infinity of 1 over k plus 1. Of course, as k goes to infinity, that's just going to go to 0. And since by the ratio test it's 0 or less than 1, therefore this sequence, 1 over k factorial, converges. This sequence, 1 over k factorial, converges. The series, 1 over k factorial, converges.